Hello, I'm Ernesto Hernandez. This is the video of the final homework of the Finite Elements course. For this homework, we had to do a saddle shade structure with Python and Gmesh. I chose a geometry with a 4.6 millimeters thickness. This was the maximum thickness I could use without surpassing the 120 grams of the maximum weight of the structure. I chose a minimum height of 20 millimeters and a maximum height of 85. I didn't want it to be too steep because I thought that would have been better for the structure, but after doing the optimization process, I realized that the steepest was the better. About the finite elements model used, I used a TED4 model with three different mesh sizes, a coarse mesh, a medium mesh, and a fine mesh. The fine mesh was the one with the better results, but also took way longer than the others. It took more than double the time than the medium mesh. So that's why for the optimization process, I used the medium mesh and not the fine mesh. Even though I used the medium mesh, it took over 300 minutes to run the 125 possible combinations. So it was still a very hard work. About the critical stress location of the structure, for all cases, every mesh, every optimization case, the baseline case, everything was always on the corner on the support. So here, as you can see in the model, on the optimization strategy, I use a parametric grid search with 4 cycles. This isn't the best or the most optimal, but it's the safest. I tried every possible combination, extract the eta value of every combination, and get to the best possible combination that's inside the 120 grams allowed for the competition. Uh, about the prediction error of the physical test results in comparison to the Python results. The Python results, as mentioned before, through the failure or the biggest problems on the supports on the corners because it didn't consider backlinking. But my structure failed here because of backlinking of little walls, as you can see in here. So that was the problem, and it allowed almost over 4,000 newtons for the structure.